Having introduced the concept of a force, it's good to have a quick index of different forces you might encounter. This is not exhaustive, rather it's just some of the common ones you will see. We'll discuss these in more detail later. First, weight. Weight's just the force of gravity. It's a long-range force where the Earth is acting on the object. Remarkably, all objects with mass exert a gravitational force on all other objects with mass. So you exert a force on me. That force, however, is really small, and most of the time, we only need to think about the force of the Earth on an object. Weight always points towards the center of the Earth, and its magnitude is fixed, W equals mg. Spring forces. When you compress a spring, it resists and pushes back. When you pull a spring, it resists and pulls back. The longer you stretch it, the stronger the force. This is the most intuitive example of a variable force. The spring will change its force depending on how much it's stretched. Tension. We call the force exerted by a rope tension. If you think about a rope as a really stiff spring, this is essentially the same as the spring force. What makes ropes fun is that they can transmit forces around corners. We'll talk more about this later. Contact force. If I push on something with my hands, we call it the contact force. Traditionally, we decompose the contact force into two components. One perpendicular to the surface, one parallel to the surface. We call the parallel component friction. We call the perpendicular component the normal force. This is because normal is an archaic word for perpendicular. The normal and friction forces are not actually two different forces. Rather, they are the components of one force. Of course, by the principle of superposition, we can treat them separately. All introductory physics courses that I've ever seen think about the normal and friction forces as distinct objects. There must be a good pedagogical reason for that, and I'll follow suit. But it's useful to point out it's just convention. Normal forces are confusing for two reasons. First, the name is weird. Second, it's a variable force. If I put an object on top of a book and it doesn't slip, burrow into the book, or fly off, then apparently the book is applying exactly the right force to balance gravity. How does the book know how much force to apply? I always assumed books weren't that smart. Microscopically, this works the same as a spring force. The surface of the book deforms when I push on it. The more I push, the more it deforms. It's just a really stiff spring. We'll often use phenomenological arguments to solve for the normal force. You'll become very adept at that. The parallel component of the contact force is friction. Friction has some complicated behavior, and it's useful to distinguish the case where the two surfaces are stationary with respect to each other from the case where they are sliding past each other. We refer to these as static and kinetic friction. Friction always opposes the relative motion of two objects. Note, this does not mean that it always slows you down. Imagine you put a box in the back of your pickup truck. When the truck starts moving, it's friction that accelerates the box. Fluid forces. There are a number of fluid forces. The book mentions drag and thrust, but also buoyancy and lift. Air resistance is another word for drag. We saw a model of it earlier this week. Electrical and magnetic forces. These are the only other long-range forces we're likely to see in this course. You'll learn a lot more about these in Physics 2208.